In problem number 4, PR is given as a length 70 and QS is given as a length 60. You're told that they intersect at point T and that the measure of angle PTS is 65 degrees. That asks, is triangle PST an acute, right, or obtuse triangle? So we're looking at this triangle in here, PST. And so we know that diagonals of a triangle, or of a parallelogram, bisect each other. So that means that each of these lengths is the same, giving PT a side length of 35. And it also means that these two lengths are the same, giving ST a side length of half of 60 or 30. And so really what we're looking at here is triangle PST with an angle of 65 degrees here, a side of 35 and a side of 30. And so what we need to do to figure out what kind of a triangle this is just use the law of cosines and solve for this the missing pieces of this triangle. So we have SAS, which means we're going to use, again, the law of cosines. So if we find PS first, we'll call this T. So we can set up the equation T squared is equal to the sum of the squares of the other two sides minus twice the product of those sides times the cosine of the angle opposite T. And so we can solve for T here. If I plug this into my calculator, I'll use the solve feature. T squared is equal to 30 squared plus 35 squared minus 2 times 30 times 35, all times the cosine of 65. I'll put a decimal in there, so my answer is displayed as a decimal. And I'm solving for T. So I get T is 35.2 approximately. And so right here I can see I don't even need to know what the actual angle measures are for this to understand that my longest side is opposite my largest angle. So there's no angle that's greater than 65 degrees in this, so I know that I'm dealing with an acute triangle. If I wanted to, I could specifically find what the different angle measures are now using law of sines, but because I know that this is the longest side, no other angle is going to be greater than 65 degrees.